Hello, everyone. Welcome to the BIM and for Architects series. And for those who joined again, welcome again. But for those who are new to this session, this is already the fourth session. And so previously, we already talked through what is Archicad and BIM and about the sustainability of this Archicad software and the visualization technique. And this session, we are going to talk through the computational side of this software, how it can be the game changer for the software in the future for BIM use. Yeah. So you know, how do you pronounce your name again?
Yeah, it's complicated. It's Eugenio.
Eugenio, yeah, better pardon. So Eugenio will give us a talk again and explain us what it is about. Yeah, so I'm gonna hand it over to.
All right. Okay, so can you see my screen? Okay. All right. So yeah, thank you, Vivian, and thank you, AIA Hong Kong and Riva Hong Kong chapter for inviting me to do this presentations in this series of BIM for architects. So today we're going to talk about the combination between BIM and computational design, which we call it the game changer because it's what really can enhance and give a huge amount of possibilities for the workflow of architects. Well, first of all, I think introduced myself in the previous sessions, but I work for Graphisoft as a BIM consultant, and I work together very closely with our customers. But my background, I'm an architect as well, and I have almost 15 years of experience working in projects. And yeah, I'm ARB registered in the UK and also Hong Kong Institute of BIM member. So let's start with what is parametric design. Let's start with the basics and what is good for. So probably most of the architects have heard about parametric design or computational design, or even have used it. And it feels like these images are like the most impressive side of this concept. We talk about algorithmic design, parametric design, computational design, or generative design. We all imagine all these amazing, super cool and challenging geometries, which of course is true that we can achieve them thanks to these methods. But the reality is that it's a methodology itself. So usually as architects, we'll get a lot of inputs like regulation, time, money, function, client, environment, a lot of different aspects that we need to solve. And then we'll come with solutions, come with projects and proposals. But of course, we all know that architects, we have a very, very tough life already early from university, but also in our professional life, we end up working very, very hard. So what is supposed to help to this daily task about developing projects is that with the idea of computational design is that we get all the inputs and we develop these codes or these algorithms in order to generate solutions. So the idea is that we generate a system that creates solutions by itself. So we can generate way more solutions, and even solutions that are more challenging, that sometimes will be impossible to do them if we try to achieve them manually. So why is algorithmic design important? Well, probably a few projects will come to your mind when we talk about this methodology, but it's not only about the beautiful geometry, it's also about optimization, about saving time, and about automation. So design methods, we will have, we, of course, as architects, we probably, most of you still design by hand, right? We like to hand sketch because it's the most immediate way of thinking and designing and coming up with ideas. And then we will use computer to, bring these ideas into this, for example, in the case of Archicad, we'll bring it to BIM, which means, we'll have a virtual project that can automate documentation and information. But of course, when we go a bit farther, we go a next step and we start we go into the realm of programming or creating algorithms. We can really automate this workflow to another level. So first of all, to understand why it's important, let's talk about our industry and other industries. So as you know, for example, the case of agriculture, we can see here, a drone that has its own system of GPS, and basically this drone develops the task of, irrigation of the plants and taking care of them, and it can automate a lot of the functions for this industry. All right. Of course, in the industrialization, the industry 4.0, the digitalization of the industry, we have managed to automate most of the manufacturing processes, even getting to levels in which machines in a very efficient way develop the work we used to do manually. As well, in the medical field, medicine, or in the pharmaceutical industry, we have got into crazy amazing breakthroughs in which we can really cure disease that we were not able to cure in the past. So we have evolved a lot in this way, right? But what happens when we compare all these industries, like medical, agriculture, industrialization, manufacturing, with our industry, with the construction industry? Well, unfortunately, our industry in the 70 last years has improved efficiency in almost 6%. Which I believe is quite poor. So I think that I already mentioned in my previous presentations that all this idea of BIM, computational design and technology, for me, I sometimes like to say, I feel like the bad cop talking about this, but it's more about a responsibility than anything else. Where other industries have evolved, becoming 760 times more efficient, okay, or 760%, or even multiplied by 15 the efficiency, we are still lagging behind. We still are very, very inefficient. That also has an impact in our economy, in our development, and in our environment. So after understanding that we need to improve, we need to change the way we do projects, we need to look forward, and we need to again improve the way we work, right? What's Rhinoceros? I believe, and I hope that most of you know what is this software about. The Rhinoceros is a 3D modeling tool, 3D modeling software that is very intuitive and allows us to create very, very complex geometries. Okay, could be a simple introduction. But in terms of which disciplines use Rhinoceros, we not only have architecture, but we have interior design, product engineering, jewelry, manufacturing, and vehicle design. All these industries use Rhinoceros 3D. Footwear design, all sorts of different design industries that really are related with, technology and engineering and design, movies, you name it. Rhinoceros is a really powerful tool in many industries. So one of the important aspects of Rhinoceros is this way of handling geometry that is called NURBS. Okay, it's non-uniform rational B-spline based on modeling, which means that we can create geometry using some rules with some control points that can give us, control and also the complexity of the geometry that we develop. But what is Grasshopper? So Grasshopper, I still have colleagues, architect colleagues, that when they look at this, they say, well, you look like an electrician or an electric engineer, connecting all these cables. So what we see here, and probably you all know, is called visual programming. Okay, so we program visually tools and commands and boxes that create tasks, create actions. But how is algorithmic design? How it looks like when we go back in history. It's not really something about the present. So algorithms, or this calculation at the end, what they do is that they get the inputs, okay, the constraints and the logic, okay, of the problems we want to solve, and they give solutions. But for example, if you look at Gothic cathedrals, they don't have a random or by chance geometry. The way they look, they respond to input, respond to the structural requirements of the construction systems. In this case, the rock. Or if you say the image of the left, Gaudi was a Spanish architect that it will calculate the geometry that the compression structures that will have to be built by hanging ropes, and those ropes will have the geometry that they will have to have when they become a solid structure that instead of tension reacts to compression. Anyway, it sounds a bit complicated, but all this, what I'm saying, like, we have been using logic and try to understand the requirements of the problems we have to provide solutions. So generative design is not about designing the building, but it's about designing the system that builds the building. So generative design, is also is not exactly the same as algorithmic computational design, but it's design in which we create a system that then generates options, generates solutions. The idea is that we wouldn't have imagined or get to these solutions by ourselves, more or less. So what about optimization? So finding, we can also use these tools to analyze the solutions we create and try to optimize them based on certain parameters. So we can do simulations and we can optimize depending on certain parameters I was saying. For example, for energy analysis, we can input, we can create a solution, but also then we can analyze it and say, okay, what is the best, modification, or what is the best result from the solution to have, for example, less solar gain. Okay, or how is the solar gain or the solar impact within a room? We can do sun studies. We can do all sort of, performing all sort of analysis, trying to optimize what we look. For example, view optimization. When we have several towers, when we have, a complex design, we also can try to understand how is the views from our project, right? And then as well, all these manufacturing, breakthroughs like robotic arms, CNC, laser cut, or whatever, they all use, they can use these rules for the manufacturing process. For fabrication with different techniques. But also, as you can see, we can also input the logics of the structural, demands of a construction and get to the result of how to optimize that structure. It's not only for architects, it's for engineers, contractors, a lot of players on our industry, on the construction industry. So, algorithmic design in BIM. So how are we affected? We talking about Graphisoft, Archicad. Probably many of you use a BIM solution, but how these two how they say lines of development or tools, okay, or methodologies better work together. So in our case, already many years ago, 5 or 6 years ago, Graphisoft developed a connection with Rhino Grasshopper because, we say, let's connect the best of both worlds. We believe Archicad is probably the most powerful BIM solution for architects. And we believe that Rhinoceros and Grasshopper are most powerful or one of the most powerful computational design and 3D modeling workflow. So this curve, which looks very complex, but it's actually developed together with one of our customers in Singapore, ADAS, probably you heard about them. It shows something very interesting, is that we have one curve, the orange one, that says goal continuous information collection. So we have a continuous workflow. We will always, reuse the information in the most optimized way. But for example, to understand this, if we look to the other little curves that said planning, design, construction, in a broken workflow or a workflow that is still the most common in our industry, this is what we have to change. We start the planning. When that phase finish, then we start again the design. Then we start developing the design, and then when the design is done, we change the tools we use, and then we start developing the construction documentation. So we always stop that process from zero, and then we have to do all this abortive work. A very common example is that most of the architectural firms don't use BIM for design. And in this, I would like really to understand your feedback. They don't use BIM for design. So they design with some tools, and then to move into the production of documentation phase, they rebuild what they designed in the BIM software, which is a huge waste of time. A really waste of resources, a lot of aborting work. So what we propose from Graphisoft is that Archicad allow us to start designing, to have from the design to the development of the whole project without losing time, without wasting information. So the traditional algorithmic design workflow, or you have used it yourself in the past, is that, Rhino and Grasshopper can create really, really easily our design, and then we export from our 3D model to AutoCAD all sort of 2D drawings, 2D CAD, slices, sections, or plans to then keep drawing manually the project, right? So all this, flexibility and design control is lost once we go into this 2D platform, because then we start to draw again. And if we have to do any change, we need to start redrawing again. Waste of time. What do we propose with Archicad, because Archicad can go from the design to the construction documentation stage, is that this integration goes all along the development of the project, keeping that flexibility and that design control throughout the whole process. So how does this work? So let me show a small video. Okay, oops. Okay, so what we have here on the image is, on the left side, we have rhinoceros. On the right, we have grasshopper with our algorithm, in which we can see that we have, for example, a few families of course we have created: the slab contours, the structural core curves, and the columns. Okay, so just a simplification of what we have. So in this case, we have a lot of just three-dimensional curves. Okay, but when we go into Archicad, and now we have Grasshopper on the left side and Archicad on the right side, Archicad gets all these contours, all these curves, and convert them into real BIM elements. In this case, slabs, elements that have information, geometry, they have quantities, we can extract dimensions, parameters, and we can extract documentation. So Archicad completes this stage in which we really can create a fluent workflow, in which all our design basically becomes the virtual project. And then from there, we can keep doing modifications, and the design in Archicad, the model in Archicad, the project, will be updated. So why does it worth it? Again, this live connection, what tries is to keep that loop, keep that flexibility from Rhino Grasshopper within Archicad, within the BIM platform. So this is this connection, which is back and forth, okay? From Rhino Grasshopper, Archicad, back and forth. So apart from creating very, very challenging designs, one thing is to have that design into rhinoceros, which is just 3D elements, curves, lines, geometry. But in Archicad, there are really smart elements. There are parametric elements that have information that can complete everything that is needed for construction. Okay. And again, probably those that don't use BIM or don't use BIM and computational design, you will have to draw those sections, those floor plans manually. If you use CAD, every time you do a change, somebody needs to come draft and, do the monkey CAD work, draft, spend a lot of time, drawing, whereas Archicad does the job for us. So if we have a model like the one we have on the right side of the screen, we can extract this documentation. And if we change the design, this documentation will be automated. And the same, on the planning stage, we're planning, in this case, I believe this geometry or this potential building that we have here is a little bit, how would I say, a bit too far of a, challenging design, but we already can categorize all the spaces when we design. For example, if this was a hotel, which looks like what the floor plan could be, the arrangement of the different type of rooms with all the information that is needed, we could already extract that data of square meters, type of spaces, type of 1 bedroom, 2 bedroom, deluxe room, service apartment, residential, you name it, and then you already have control over the design. And then we can also, these designs, once they're in Archicad, we can analyze and visualize the metadata. Metadata, as you know, is data that defines data. So for example, structural hierarchy, we see with different colors the different type of structural elements. Functions and categories by floor, we see with different colors, they display a color that define a type of information, all the different type of floor plans that we have. Of course, we can create extraordinary and really challenging and beautiful geometries, which again, I challenge any of you to do this design manually, and you will spend quite a lot of time. But what happened when we go back from Archicad back to Rhino? So in this case, we have in the BIM platform like Archicad, we have a lot of parameters within the elements of our project. We have the section, the thickness, the different openings, the contour, the bottom surface, the surface on the edge. We have a lot of parameters, a lot of dimensions and a lot of information in those elements. So what we can do is to extract that information and bring it into Rhinoceros through Grasshopper. Like this, for example, we have top left the Archicad model, and with Grasshopper, we extract those contours of those slabs and we bring them into Rhino, and we can modify parts of it. So in this sense, we can keep doing, editing, but most likely, analyze and keep doing tasks with the geometry we have in our project already done in Archicad. For example, in Archicad, we can create from, how do you say, like a point cloud or a XYZ file or E57 file, we can create a terrain, okay, generate automatically. But then if we bring that terrain into Rhino Grasshopper, then we can run some tools that Grasshopper has to understand, for example, the inclination of the different parts, showing those how to say inclination or values with different colors, and then that can help us visually to understand where shall we do what in which part of the terrain. So give us a lot of visual useful information to then develop the project. Of course, Grasshopper has fantastic set of tools for environmental analysis: Ladybug, Honeybee, Butterfly, and Dragonfly. And this will be the result of taking the model from Archicad, bringing into Rhinoceros, and with Grasshopper, analyze, for example, the solar gain of this little house. But also we can analyze, in this case, and another house, we could see, okay, where is the sun impacting the most? Where do we really need to put more insulation? Where we need to put more shading? Where we need to hide the glazing surfaces? And we can really give better and more sustainable responses. So, for example, we can also deconstruct parts of our building. In this case, we can have a building envelope. We analyze it in Rhino, and then we change the design. For example, in this video. So on the right, we have our Archicad project. We bring it into Grasshopper. We run the soil analysis, and we analyze the impact of the sun on the facade. And we use that information to redesign the facade. So you can see now, okay, the video starting in loop, we don't have any fins on the facade. Once we understand how the sun impacts, we design the thickness of the different fins. And then when we change something on the model, it will update in the Archicad side. And again, we have all the fins, we have all the geometry, and then we can create schedules, we can create prices, we can extract quantities, we can do elevation sections. And this workflow is only possible when we use this combination of tools, algorithmic design and BIM. Then we can also do all the things, which is in this case, for example, oops, 1 second. So in this case, when we have this set of balconies in Archicad, we can bring the elements that we have on the Archicad side, or it's the curtain wall or the balconies, and there we go. We have what we have in Archicad before, we have it in Rhino and Grasshopper. And then we can extract the contours and do some modification and develop some options and bring them back to Archicad. Like, for example, automate the generation of the fins on the facade that are not on the balconies, because on the balconies we need to have access. Okay, so we cannot have that that obstacle, okay, on the facade. So as you can see, when we do modification, the handrail updates, and then the facade updates. We extend the balcony, and then the curtain wall opens, okay, and we can generate as many design options of a facade, or even create this more funky how to say handrails, or more simple. But again, this is not a crazy geometry, but you will save time if you do this in an automatic way rather than doing it manually. And again, thanks to Archicad, we have the elevations, the sections, and we can really communicate our design in a more accurate way. So let's see some examples of this workflow. How is this used? Let's have a look to this project. It used to be the signature project of the Archicad 23. Now we're in Archicad 24. And this signature project is from a Russian architecture office, which is called Pride. And the project is the Rhythmic Gymnastics Center of Moscow. And of course, we have quite developed and crazy and complex algorithm, we can call this. Yeah. So the idea is that with this all this combination of actions and commands, we develop this complex surface, okay, but also then we develop everything that is needed to get it built. We can measure the curvature, we can measure the degrees, but also we can then, from this geometry, extract all the information, for example, to create the structure. So, all the structure requires one of these three-dimensional set of not beams, but it has another name. But anyway, these spatial structures, okay, three-dimensional, that can hold and is optimized to hold this roof. But again, what's the advantage of having this only rhinoceros? But if we bring it into Archicad, then we can develop everything else, or we can collaborate with other consultants to develop, the MEP systems in using BIM, and then we collaborate with them. And again, another one of the advantages is that we can generate all this documentation for free. We can just make the output from the project. Archicad does it for us, and we can save a lot of time and a lot of costs. And at the end of the day, what we want is to present our idea, our design, and build it as better as possible. Another project, in this case, this is a library in Norway, okay, from another customer, which is Helen and Hart. So Helen and Hart in Norway is very common to do projects using timber for construction, both for structure, for the facade, and for the other parts of the building. So the idea of this project is, you have this kind of organic, biological shape, that goes around, and we have the different space of the library, and all the structure of the different parts of different elements are slightly modifying to accommodate this geometry, but also they have the necessity of solving the structure and the structural requirements and other requirements. So again, you can see here, for example, in this image, that those, how could we call, not beams or columns, but those like fins, wooden fins, okay, that conform like both the how I call the column, if you want to call it, together with the beam, it's like a rib. It's like the shape, of a weird rib. It's called continuous. All of them are different, but all of them are already designed, so we know where we need to cut and how we need to produce it and how we need to build it. Then this is a funny example, very, very different from the others. This is another Russian user that used Rhino and Grasshopper to design and apply all sorts of, a combination of prefab sandwich panels for the facade. And what it does is that they analyze the shape of the building, and they panelize, make the panels of all the facade, they modulate it, and then they add the panels that are needed. And then, of course, those panels go into Archicad with a lot of information. So this is the part that happens in Rhino Grasshopper. First, you have a facade, different openings. We analyze that facade and understand the different panels that are needed to build it. So all the panels are modular, but using some module, what happens at the end, each panel, not each panel, but a lot of the panels are different. And this is because of this image that you can see here. So you can see that it's a module, right? We have a height, we have some profiles, but every panel can be slightly different, can have a few more modules, few more heights, can be in the corner, but then we can build it. We can rebuild the whole panel, with the structure, substructure, the insulation, the finish, the bricks, and all what is needed. And then we bring these panels, in this particular case, as GDL elements into Archicad. GDL elements, just as a little break, is one of the is how Archicad builds the three-dimensional library, or the library of objects. That makes they are very, very light objects. So that's why Archicad works in a very fast and very smooth. And we bring these elements into the model, and then we can see, this will be selecting those elements into Archicad. And from them, we can extract, the amount of insulation, the amount of profiles. I believe that as far as we want to go, we could even understand the amount of screws and the amount of bolts that we have to, to fix them. So we can go very, very a lot into detail when we're using this method. Another project also from Helen Hart in Norway, and this is a museum, like a Naval Museum, I believe is so kind of naval or museum, something related with sailing and boats. And again, it's not only the fact that we have a very demanding geometry, but we have a lot of constraints for using timber structure and how we need to make this structure work, for the structural requirements. And of course, I believe that all sort of energetic analysis to work properly in this type of weather, which is in Norway. As you can see, this is an elevation of the project standing on the hill. I mean, super beautiful images that you can create probably in Archicad. And as you can see, the space is really, really challenging. So we have all these wooden structures that have this, opening in the middle with this light. And again, if we want to develop this type of projects, we really need to have advanced workflow to be really able to do this in the right way. And now we go to another scale. Okay, this is Enzyme APD from Hong Kong. And in this case, this is a master plan and a landscape project. So Loop City in China, this was a competition in the south of China to develop a city that was integrated in the landscape of the territory was called Geelong, as I remember. And the idea was to create, okay, how can we create that city that integrates in the nature, trying to coexist, trying to, allow humans to live without being invasive or having to, to really separate nature from the city. So Enzyme came up with this concept of the loop city, which is a combination of loops that are combined by these kind of roads, or not only roads, but paths and how is it like, I don't know how to say the expression in English, but, like communication paths that connect whether people, vehicles, energy. It's like the veins and the the system of what gives the city alive, and it adapts to the landscape, to try to adapt to the authentic geometry and the value of the landscape, trying then to connect with these loops, which are the where these important areas are located. Okay, so this could be the result of the how this part of the master plan will look. As you can see, we have a few loops here, and we have this organic paths, this organic arteries that connect the different parts of the city that adjust to the landscape. Here, the challenge was to analyze the landscape, try to understand which parts of the landscape were going to be flooded, okay, with water, with the growth of the river, but also which were the most flat areas of the landscape, so we minimize the works of earth movement, adding and subtracting. So in this sense, is analyzing and optimizing the project. Of course, apart from having great ideas, this great execution is what gave Enzyme the first place on this competition. And of course, we can create these powerful images. I would like to add that I forgot in this slide, but this competition was done together in between Enzyme and a Japanese company called Takenaka Corporation. So they team up and they developed together this project. So I think that I arrived to the end of my presentation rather sooner than what I expected. But yeah, I'm happy to respond to any of the questions or keep the conversation for the remaining part of the evening. Thank you.
Thank you, Rhino. For people who has questions, as I mentioned in the chat room, you can feel free to enter in the chat room or in the Q&A session. It could be anything, like maybe related to BIM, not necessarily related to this software, I guess, right? To start off with, I'll start with some questions. I got some quite technical questions actually. As I see in your presentation before, you show us the relationship between Grasshopper and the module layout in Archicad. So does that mean when we try to change that modules in Grasshopper, if we produce that scripting, then it will automatically change in in Archicad, like that the module from Archicad will update automatically, like what we used to, like for Revit, for example?
Yeah, so the idea is that, I mean, I don't know if you're talking about a particular slide or particular example when you say the modules.
Maybe that slide that you show, there's one module with some interior support, like some wall supports.
Some wall supports. Wait, it's not the example of the panels of the facade?
Yeah.
Yeah, so the idea is that first there is a step, in this case in Grasshopper, in which the user, the architects analyze the facade, and in Grasshopper they create these panels. Okay, but as we were seeing in Grasshopper, these panels are a set of surfaces, lines, and volumes. And then using the connection between Rhino Grasshopper and Archicad, those geometries become these elements that are part of the construction model. So it's like completing the workflow. So the idea of the connection is that it's live. I mean, live. Of course, if you have the live connection always on and the programs are talking in between each other constantly, your computer will suffer. But the idea is that every time you update the part or the design that you have in Grasshopper, you can update the model that you have in Archicad without having to do it manually.
So that means for the supporting structure, it will create automatically.
Yes, in this case, I believe that the panels, as you can see, the supporting structure is also part of that development. It's also changing when every time that module change, or for every different module, the support structure will be also updated.
That's quite clever.
Yeah. No, it is a matter of saving time, of course, and be accurate.
Maybe for people who are new to this software, I just wonder how easy for them to pick up this software, because some of them might be students and they want to use it for their work for school, or is it okay to use for schoolwork, or is better for commercial world? Does it, like, how hard or difficult? I mean, easy?
Well, I mean, learning Archicad is relatively easy. I mean, if you compare to, for example, Revit, you were mentioning, most of our users prefer Archicad to Revit because it's easier, simply. And then Rhino Grasshopper, I mean, it's not super easy to get to certain levels, right? But there is a lot of architects that are very good on the Rhino Grasshopper side, and I believe that the idea is to team up and collaborate together. You know, having, whether it's in university or in the real architecture practice, right? I mean, probably, I don't know. I don't know if some of the people joining the conversation, do they use BIM in their company, but do they also use some sort of computational design? We also like to hear from them. Actually, we have a couple of questions. I don't know if
I saw. So Jamie is asking, do you think that McNeil will implement Rhino inside Archicad, similar to what has happened with Revit?
Yeah, I think that, I'm not sure, but I don't think that's in the pipeline. It will be cool because Revit has Rhino inside Revit, which is very cool. But I think due to the limitations of Revit, it's harder to achieve things like what you can achieve with Archicad. But of course, in theory, the connection will be easier because you open Rhino inside Revit. I'm not sure if that's on the pipeline, to be honest. Yeah. And then, we have some other question
from Elix. So Elix asking, any idea about the limit of CD? I mean, CD stage?
Computational design.
Computational design, okay. And the idea and the area of frustration according to your experience.
Any idea about the limit of computational design? I think the limitation of computational design is more the limitations of the human. You know, what I'm saying is, like, I personally, I'm not particularly myself an expert. I've been always working with colleagues. I always use it, but I always had colleagues that they were much better on the computational side. And when you don't know how to achieve something, you keep learning, you keep studying, and then you achieve things that you will not thought that you could achieve. And I think that's the power of computational design. I think the frustration comes every time you want to learn something new. I think that's in general.
When you can't build something that you want. So
yeah, exactly.
So there's another question from someone doesn't want to show the name. So anyway, so I'm gonna ask. So Archicad itself cannot perform the automation as it needs the Grasshopper to input the parameter.
Well, the automation depends. Archicad can automate the documentation. So that's for me a great level of automation, because when you want to extract documentation from other BIM solutions, probably you know that the quality is not the best. The quality of documentation from Archicad is, I remember in all my years of experience working with Archicad, every time I will print my drawings or share them, everyone will ask everyone will tell me how good I am drawing in AutoCAD. And I said, look, I didn't draw a single line. I don't want to waste time on that. In terms of the computational design, yeah, I think that the purpose in that sense of Graphisoft is, instead of, like other BIM solutions have, I think, for example, Vectorworks has Marionette, Revit has Dynamo. But at the end, I don't know if this is politically correct to discuss, but all these computational tools are originally a copy of Grasshopper. So I believe that what Graphisoft wanted to do, which could sound lazy, is like, look, we don't want to reinvent another computational tool that is going to be worst. Okay, let's connect with the best one. So what they do is create this connection. So, I think that's also a quite interesting approach. It's like, look, it's like, instead of having to learn everything myself, why don't collaborate with people that know better all the things? So I believe that's the purpose.
Yeah, sure. Another question from Wu Hyun. I guess apologize if my spelling, pronunciation is wrong. But so Wu Hyun is asking, actually is a comment say, surely understand how good it could be to use Grasshopper for complex geometry. However, I always get stuck with my PC since it makes PC super slow to when it has some later complicated geometries, So do you have any recommendations on the PC specification for Grasshopper, for example? And would you compare Grasshopper versus Revit for the same parametric design in terms of easiness to learn and use?
Compare Grasshopper and Revit. I think they're very different in that sense to learn. But for the PC requirements, it's funny because I use Macintosh, and I think Macintosh is they have quite good machines, but in particularly for Grasshopper, the best are the PCs. It's much more stable in PC, and I think that, of course, depends on what you want to achieve. If you want to do something very, very crazy, your PC is going to suffer. But all these designs that we're showing here, most of them, those exercises, I can run in my laptop. Of course, the problem, what often happens, now that you mentioned Revit, is that, for example, Revit is not multi-core. That means that it will run much slower in your computer. That's why it's always stuck. Users say that Revit gets always stuck. But in that sense, for example, Archicad is multi-core, meaning that even a less powerful computer, it will run more smooth. So I think that could be also something to have in consideration. But for the Grasshopper side, I think the PC, I will be curious to see the design that you're trying to achieve that is making your PC slow, if you're working just in Grasshopper. Because for me, in Grasshopper, you can really do crazy things in the PC, in my experience.
Does that mean, if you say Archicad use one core, so does that mean it will occupy the whole PC's memory? RAM?
No, it has nothing to do with that. Actually, it's the opposite. Archicad is multi-core. So most of the computers have several cores. If Archicad being multi-core means that you use all the resources of the computer. That's why it goes faster. Okay, it's like using all the muscles. So that's where you can go faster. Revit is single core. So use only one core. That's why I mean, I would like to ask people with experience using Revit, because that's what we always get from our customers, right? They use Archicad and often they use Revit, and they say, look, the moment you want to have a project like this one in Revit, you will have to wait forever. But it's because
for like 15 minutes at least.
Exactly. No, I think that's is one of the advantages of Archicad, that is, can handle larger projects without getting stuck, because it just use more the course, but it has nothing to do with how much it occupies in terms of space when you install it. Actually, also, I don't know, but I also heard that Archicad, you install it, doesn't occupy much. It just it has another structure of how is developed the software itself.
Yeah. And I like, for those who joined new, like in previous session, there were trials for Archicad if you guys want to try. I don't know if it's still available now, if they want to try.
Well, we can, if anybody wants, I can share the material.
Yeah.
We send the links to download Archicad trial version and the exercise to try. But also, I also spoke with Winston. I mean, if at some point among, you guys of AIA and RIVA, you want to do another workshop, we can organize. If that's, if you guys want, we can organize another workshop hands-on.
Yeah, if you guys want to learn, then maybe you can raise your hand or email us afterwards, or just leave a message so we can get a head count of who will be interested to have like a more dive down training for these kind of sessions, and so we can organize more.
Yeah, exactly.
Anything else you want to show? We still have around 10 minutes.
Yeah, I think I went a bit too fast today. I saw a video the last time. It's like 4 minutes. I don't know if I saw a video when I did a presentation about just BIM in general. But maybe, I don't know, maybe it's interesting. It's about the so I don't have to open all the files. About one project I was doing, just one, design test in between, BIM and computational design. So this will be, can you guys see the video?
Yeah.
Okay, so the video is 4 minutes. It's accelerated only, I think 50%. So this workflow that I'm reproducing here in real time took me like less than 8 minutes. Okay, so what we have basically is one script in Grasshopper that is not that complex. You can see it here. Okay, and then we can see on top in Rhino what is generating. And then we will see, you see all these little red boxes. These red boxes are those that are going to send to Archicad and create in Archicad geometry out of these curves. So I think it's a quite simple example to understand. So first of all, we have, Rhino Grasshopper. We can, change the way the tower is generated. So instead of a square, we can have a pentagon, different geometries. We can twist with more and more angles. We can change the scale on top. We're changing the design in a way that, again, do this manually is simply not possible, right? So we created some smooth, sexy, curvy tower, okay, which all the floor plates are different. And when we go to Archicad, okay, this is a break. In Archicad, we have one option, okay? I designed previously a tower, okay? And this is the documentation that is automatically generated in Archicad from this tower. So the connection, as you can see here, there is here, this little box is not working yet. This option that I can see in Archicad, I brought it from Rhino before, okay? And what I'm gonna do now is show you how I'm gonna delete this option, and I'm gonna activate the connection again. You see, start connection, you see the connection is running. Now all these little boxes instead of red, they're gray color, meaning that you see, you have the toggle that says false. Every time we click true, means that those curves are going to be sent into Archicad, and they're gonna become walls, zones, spaces, slabs. So you can see, this is what was happening in the background, so that we deleted. So we have passed first the zones and the slabs. Now we're gonna bring the shading elements and the slabs. So let me just stop here 1 second. I cannot stop the video. Anyway, wanted to show. Okay, sorry. Yeah. So what I wanted to show is that here. Okay, this is, I need to close it. Here we have something that says slab, and then we have a fabric. So Grasshopper is reading, let's say, styles of slabs and styles of shading of fins from Archicad, and then is converting these curves, okay, this geometry, into the BIM elements. So first you see that it brought the fins, and then you can see that plop appears the structure. So what I like to show this because, you know, even already on the BIM workflow, in the BIM world, a lot of BIM solutions don't work well with curves. Okay, see that go very slow. Just look at this geometry. All the curves are different. And all the curves have quite level of complexity. We can turn off some of the layers, turn them on, turn off the, you know, the surroundings. And now what we're going to go into Archicad, okay, we break the connection, so this box become red. We turn the connection again, and we're going to bring the columns, the last part. So you see, applying changes from Grasshopper, Archicad is updating the elements from Grasshopper. And if you look at the tower, you will see, oh, we have those columns that before were just lines in Grasshopper, and they come into Archicad. And if we do any change, we start the connection again, and the design automates. Now we go to the drawings, and again, I want to stop. This that we can see here are the drawings of the previous design. They are not updated. In Archicad, you can update manually the drawing. So this drawing shows still the old tower that we deleted. So now we're going to select the drawings and say update. You see, update. And then, of course, we're generating a lot of geometry, and pop, the section automatically updates. So again, usually, you know, without BIM, we'll have to create these CAD elements from Rhino, open them in AutoCAD, pick the thickness, put the levels. I mean, it's a huge waste of time. How much did it take? Like a few minutes. And I'm just saying this because if you try this in Revit, probably will explode. But you can have a super crazy tower with crazy amount of polygons, and we update the elevations, we update the section, we update even that schedule, which shows the GFA per floor. You see the numbers change. Now we have like 200,000 square meters, a gigantic tower. And then we update also, and all this information that comes per floor, you know, from the different spaces are updated. And then we update the floor plate, and you see it was triangular shape kind of before, and now is like, you know, more is 4 sides, right, with a fillet. And then this is another step. Okay, this took like a few more hours of development, but here now we have the facade, we have a curtain wall. And again, just look at this, look at this amount of geometry. Not even talking about how to do this in 2D, okay, but you will have to do this in Rhino, extract in 2D, bring into your CAD software, and you know, if you use all, as I said, I would like to ask the experience of those using other software like, I don't know, Revit, Vectorworks, Allplan. How is the experience when you put this such a gigantic projects with this amount of geometry?
Slow.
Yeah, of course, it takes time, but as I said, in that sense, Archicad is quite strong in the way you use the resources of the computer.
So I have a feeling for this one, then you need to use Grasshopper a lot. So for people who is not very advanced in Grasshopper, they need to have a tutorial for that before they're using Archicad.
Yeah, but for example, this exercise I show, I mean, this exercise, my idea was to prepare these files, so to give the students this script, Rhino file, and Archicad file, and just do with them what I'm doing here, which is just with these slides. You can see that I changed the radius, the segments, I changed the geometry. It's already set up, so I just changed. You see, if I say segments 0.5, it goes to 4. So we just use the script to change a bit the design from these parameters, and then we bring the elements to Archicad. So this workshop could take also, I think that maybe 1 hour, but again, this is, depends on the machines we're using. We need to do step by step. So we need to do it with calm, because with certain experience, how you should do each step. If suddenly, what happens sometimes is like you say, oh, I can put, in one of these sliders, you have like the amount of floors. Some people say, okay, I can go up to 1,000 floors, and then you rise the slider up to 1,000, and of course your computer crash. So you need to, it's like a powerful weapon that you need to control, right? So, or even, you bring that courting wall from Grasshopper to Archicad, and the amount of polygons and geometry that has, you need to do it in a way that, you have a simplified visualization. So you don't see all the geometry, just see a simplified version of the courting wall. So there's a few steps that we need to learn to use this to achieve this type of design. So but I think again, I spoke with you and Winston. I think that later on the year, if people is interested to learn Rhino Grasshopper, we can do a workshop. Also, touch wood, if at some point we can meet in person, that will be even more fun. I think it's more fun to do workshops in person. Sure. And then,
this is not an easy software. I mean, it can get very complicated and could do all sorts of things you want to do.
Yeah, I think in person is more fun. It's also easy to see what the problem of people are finding and solve the issues.
Let's hope the situation will get better. Yeah. So is there any more questions from the floor? That's a bit quiet.
Yeah.
So there will be next Tuesday will be the last session with this software, and we'll go through the documentary side of this software and how you can like produce drawings, right? Correct me if I'm wrong. So we'll be talking about how to produce drawings, like some technical side of.
We will go more in the detail of how to automate certain type of documentation, and we'll see, design drawings, construction drawings, GVP submissions, which I think in Hong Kong are quite relevant. So we will look into that. It's more like the drawing package delivery using Archicad.
But again, don't worry if you don't have that software ready. You can just like log in and listen, and you can have the software later on to practice, and then ask us if you've got any more questions. If you don't have any, do you have anything to add? Not, we can.
No, I think from my side is fine. It's almost 8:30, so I think we did it quite well in time.
Yeah, sounds good. Well, thank you everyone for joining. So
thank you everyone.
I will see you guys next week, or see you guys later on if you're busy. So so enjoy your night, everyone.
Thank you very much. Bye-bye.
Bye-bye.